So this week we're going to take a look at section 2.2. We'll split it into 3 days. So hopefully Wednesday we'll have everything done for the week, and then Thursday that'll be our review day. So in section 2.2, we're going to look at what's called the unit circle trig. Okay, this will be the first time you've seen the trig functions in this class, like sine, cosine, tangent. If you've done them before, you might have done something like this, or this might be a little different. All right, but this will be the first time we've seen them. All right, so I'm going to start with that diagram. Okay, so what that is that's a unit circle. Okay, a unit circle is just a circle that has a radius of 1. Okay. The kind of trig that we're doing, we can do it on a circle that's not a unit circle if we want, but a unit circle is easier. That's why we did it that way. So a unit circle has a radius of 1. And the idea of unit circle trig is you can take and draw an angle. That'll be my initial side. That's my terminal side. And I could have put that terminal side anywhere I wanted, okay, but I chose to put it like that. But no matter where you put it, it's going to hit the edge of the circle somewhere. In this case, it hits right where that purple dot is. The goal of unit circle trig is to figure out the coordinate of that dot. And then we do something with that coordinate. That's the goal, to figure out the coordinate. So there's a certain amount over that you went, and then there's a certain amount up. The amount that you go over, that's the horizontal distance, that's x, and then the amount you go up is y. And by going over and up and then looking at that green terminal side that I drew, what shape did I make? Yeah, I made a triangle. So when we do unit circle trig, we're going to be working a lot with triangles. Even though it's a unit circle, we still make triangles. And depending if you were over in quadrant 2, we could do the same kind of thing, but in this case the x would be negative and the y would be positive. Okay, so we'll practice doing it in quadrant 1 first, and once we know that, doing it in the other quadrants, it's very similar, just with negative numbers. So any question on the idea? It's finding the coordinate of where the terminal side hits the edge of the circle. All right. Now, for certain angles, this works very well. Okay? And the angles that we're going to work with are multiples of 30 and 60. So any angles that are multiples of 30 and 60, actually I'm going to change that. Because that comes out. Let's do it like this. That's better. 30 and 45 can be represented as a coordinate. So if we're working with angles that are not multiples of 30 and 45, this whole thing I'm showing you isn't the way to do it. If you're working with an angle that's like 12.4 degrees, for that, we're going to use a calculator. And this is the whole goal. If we can't figure out that coordinate, we're not going to be able to do unit circle trig. And because we're only working with very specific angles, okay, angles that are multiples of 30 and 45, so one's like 30, 60, 90, 120, 150. Right? Those are your multiples of 30. And then multiples of 45 are like 45, 90, 135, 180, 225, things like that. Because we're only working with certain angles, we're only going to see certain coordinates, and we're going to start to see patterns in those coordinates. And there's not going to be a lot of different coordinates we have to know. Now there are 2 directions we can rotate. In this case, I went like that. Does anyone remember if you rotate counterclockwise? Is that the positive direction or negative direction? Yeah, that's positive. If I went clockwise, that would be a negative. Yep. In general, we'd rather work with positive angles than negative angles. Positive is just easier to do the arithmetic. So I'm going to bring up a diagram. I want to take a look at it. I'm going to put a negative angle up, and then I want to see how we could make it positive. All right, so here's a diagram where I've drawn an angle. Again, I can't move the initial side, but I'm moving the terminal side in a clockwise direction, and I moved it to negative 90. There's something I can add to that, and it would make the angle positive. Anyone have an idea how much you could add to negative 90? This circle still has to land in the same spot. It has to be at the bottom when you add the number that I'm thinking of.
360.
Yep. If you add 360, that's one time around the circle. Okay, watch what happens to your angle. Okay, so here's negative 90. I'm going to add one revolution, which is 360, and I get 270. So negative 90 and 270 have the exact same coordinate. I know the number over here is different, but I'm not going to worry about that. I'm just going to worry about what this coordinate would be. Right? And if I did it again, 630 would also have the same coordinate because this red circle is in the same spot. Right? We don't want to add 360 too many times because then we're going to get an angle that's too big. The goal is always to get something between to get something between 360 and 0. If you had an angle that was too big to work with, what do you think you could do to that number?
Subtract 360.
Yeah, you could subtract 360. That's one time around the circle. It'll bring you right back to where you started, same coordinate, but smaller angle to work with. So if you have an angle that is greater than or equal to 360, you can subtract 360 as many times as you need to until you get the angle between 0 and 360. Okay. Same thing if you have a negative angle, you can add 360 as many times as you need to until you get it between 0 and 360. That's always the goal. Any question on that idea of adding or subtracting 360? Now, what would that be in radians? Adding or subtracting? How much is 360? Two pi. Yep. Because pi is 180. So 2 pi is 360. So what I'm going to do now is I'm going to give you the definitions of the 6 trig functions. Every definition is going to involve one or both of those letters, and those letters are the coordinate of that point right there. Okay, so you have to know how to find that coordinate. So there are the first 3 trig functions: sine, cosine, and tangent. These are function names. Examples of other functions we worked with this year: log, squaring, that's a function. Square rooting is a function. They don't have special symbols like square root does. There's a special symbol for it. These type of functions, we write out the word. That's how you use it. Because we have to write out the function and there's no special symbol you can use for it, they all have abbreviations. Every trig function has a 3-letter abbreviation. It's usually the first 3 letters of the word. And for these 3, it does follow that pattern. Now, when you have a function, it doesn't do anything for you unless you fill something in. Like if I said to you, what's the square root? What would you tell me? What's the square root? What's the answer? We don't know. Square root of what? What do you want to fill in? You want to put in like a 9 and then we can get the answer. Same thing with sine, cosine, and tangent. If I press sine and I said to you, what's the answer? Well, sine of what? What do you want to take the sine of? You need to fill in something. Right? Like you could put in 30 and you get an answer of 0.5. Right? So you have to fill in something. What you're filling in right here, this number, that is an angle. Okay, so in this case, it would be the sine of 30. And would that be radians or degrees? Degrees. Right. I know it's degrees because that's the mode on my calculator. If I want to do radians, we can change the mode. And I'll talk about how you do that in a little bit. Okay, so that's the first thing to understand. Okay, these are all functions. And to use it, you have to fill in a number in that spot. If you don't have a number to fill in, well, we can still figure it out, but then we have to use these definitions on the right-hand side. Right? And that's what unit circle trig is. Okay. So we're not going to be able to use a calculator on these first few problems because we're not going to know what number to put. But we are going to know what coordinate to put. And that's just as good. Okay? Knowing the coordinate is actually what we need. If I ask you for the sine of an angle, you need to find the coordinate on the circle and then tell me the y value. If I ask you for the cosine, you're going to tell me the x value. And those are the easiest two. Okay, all the other ones are going to be fractions. Tangent, you're going to have to find the coordinate that I pointed out on the circle and then divide the y by the x. So those are the first three. Second three. The cosecant, the secant, and the cotangent. And there's a reason I wrote them in 2 columns and 3 rows. I want cosecant across from sine, secant across from cosine, and cotangent across from tangent. Okay. All of those also have 3-letter abbreviations. Now, one of them on the right, the abbreviation is a little different than the pattern I've described for the abbreviations. Which abbreviation is a little different? Yeah, cosecant. Why? What's different about that one?
It's not the first 3 letters.
It's not the first 3 letters, and it can't be the first 3 because you've already used COS somewhere else. So they use the first letter of each syllable. Co, C, cant, CSC. All of these trig functions also have to have a number plugged into them to be able to do it. Or if you don't have the number, you can use the coordinate instead. All right? And that's, again, what we're going to do. We're going to use the coordinate. Here's the first one. The cosecant is the y value flipped. Does anyone remember what's the name of that when you take something and flip it? Yep, reciprocal. They're all reciprocals the way I paired them up in these rows. So what do you think the secant is?
1 over x.
It's 1 over x. And how about the cotangent?
X over y.
That's going to be x over y. Yep. So for all the problems that we're going to do, at least to start, you are not going to know the number to fill in. You're going to know the coordinate, or you're going to have to figure out the coordinate. And that's all we need. Okay, so I'm going to show you how to do it with the coordinate. There are 4 coordinates that I think we could probably figure out, or 4 angles that I think we could get the coordinates for right now. And that's 0, 90, 180, and 270. Those 4 angles are called the quadrantal angles because they're on the axes, and the axes give you 4 quadrants. Let's start with 0. What's the What's the radius on this circle?
1.
1. Yeah, has a radius of 1. So anyone think they know what the coordinate would be to get to this point?
0, 1. I'm sorry, 1.
1, 0.
Yeah.
That is the coordinate to get to 0 degrees on the unit circle. Never changes. It's just right 1. How about the coordinate
0, 1.
to get to 90? Yep, that's 0, 1. Because to get to 90, you don't have to go left and right. You go straight up. And you go up to the edge of the circle, and the edge of the circle is 1 unit away. How about 180? So 180 has a coordinate of negative 1, 0. And how about to get to 270? 0, negative 1. So those are the 4 coordinates for the angles that are on the quadrants. 0, 90, 180, 270. They're the only coordinates that come out nice. The other ones we're going to do are not as nice numbers in the coordinates. Any questions how we got those 4 coordinates? All right, so how do we do unit circle trig? 2 steps. The first step is you need to find the coordinate. Okay. If they give you the coordinate, great, then step 1's already done for you. So what would it look like if they did step 1 for you? It would look like that question right there. I'm giving you an x and a y value to work with. So you already know the coordinate. What would it look like if they don't give you the coordinate? They give you one like this. Instead of the coordinate, they're telling you the angle, 90 degrees. So now you have to go back and look at the diagram and remember what was the coordinate for 90 degrees. So we'll do some where I give you the coordinate, and then we'll do some where I give you the angle instead. Now, you're kind of wondering, well, what happens if I don't give you 0, 90, 180, or 270? How do you figure out the coordinate? Because I've only given you those 4. Well, today you don't have to worry about that. Anytime that I don't give you the coordinate for today, it'll either be this one, this one, this one, or that one. So you only have 4 to pick from. Tomorrow that won't be true, but for today it is. Okay, so step 1, figure out the coordinate. It's going to be one of the 4 on the other page, or if it's not, I'll give it to you. Okay, step 2, once you know the x and the y value from your coordinate, you're going to fill in those 2 numbers into these formulas. When you're doing a question on the test, I would probably only give you one of these trig functions per problem. When we practice, we'll do all 6. So we're going to have an x and a y value, and we're going to fill it in here, 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 and there. We'll fill it in for all 6. Okay, now, a couple things that are going to happen. If you looked ahead, you might notice that coordinate on the y value, it has a square root in it. Anytime that we have a square root, there's a chance it could end up in the bottom, especially when you take one of them and flip it. So, say we had something like that. We can't leave the square root in the bottom. Okay, we have to fix it. Does anybody remember what you can multiply by to fix having the square root in the bottom of a fraction? It's got to be the same thing in the top and in the bottom. Yeah?
The square root of the same thing.
Square root of what?
The square root of the same thing, but the square root is in the first part.
Yeah. So what would it be in this one?
Square root of 3.
Square root of 3. Yep. So it's got to be the same thing in the top and in the bottom. And then you multiply straight across. 1 times the square root of 3. And the square root of 3 times the square root of 3, that's the square root of 9, which is how much? 3. Yep. So this, that I just put a box around, is exactly the same thing as that. The only difference is this has a square root in the bottom, the circled one does not. Okay, so that's one thing that can happen with square roots. And the other thing that can happen, we've already talked about when we did the distance formula, sometimes it reduces. Does anyone remember how you can break up the number 20 as something times something? But one of the numbers has to be something I can take the square root of. 4 and 5. Yep. And the reason I wanted something I could take the square root of is because that comes out nice. Square root of 4 is 2. Okay, so that's the other thing that can happen with square roots, and we talked about that one already. This one up above, maybe we didn't talk about. But now we did. Okay, so let's look at our first question. So it says, let P be a point on the unit circle, and that point represents an angle. What angle does it represent? Well, let's go back and look at our diagram. Okay, so look at the coordinate, -1/2 root 3 over 2. Does that look like any of the 4 coordinates that we wrote in red? No, it's not. So that coordinate is not the coordinate for 0, 90, 180, or 270. What is it the coordinate for? It doesn't matter. You don't need to know that right now. All we know is that is the coordinate for something. What quadrant is that point in? -1/2 root 3 over 2.
Top left.
The top left. So it is in quadrant 2. So it is the coordinate for an angle somewhere over here. But exactly where, we're not going to worry about today. All right, so they give us a coordinate. X value is always first, Y value is always second, and we're going to fill in to our functions. Okay, let's start with the sine. Okay, what's the definition of sine using the coordinate? It's the Y value. So in our problem, what is the Y value?
3 squared over 2.
Say it again.
3 squared over 2.
3 square root of 3?
Yeah.
Yes, okay. I thought you were saying 3 squared at first. So square root of 3 over 2. Okay. What's the definition of the cosine? It's the x value of your coordinate, which was given to you. What's our x value? -1 over 2. Okay. Next one is tangent. What's the definition for tangent?
Y over X.
It's y over x. So it's y over x. It's almost like we could just put a division line right there. That's the tangent. This is y. This is x. So it's root 3 over 2 divided by -1/2. Okay, with this one, we're not going to end up with a square root in the bottom, but we do have a fraction in the bottom. We don't want to do that either. How do you divide two fractions?
Using decimals?
No, we will not do any decimals for this. So no decimals. Sorry. How do we divide those two fractions? Or how do you divide any two fractions? Like what if you had, 1/2 divided by 3/4?
Change flip.
Okay, what does that mean?
You keep the first fraction the way it is,
Okay.
and then you multiply it by the reciprocal of the other fraction.
And what's the reciprocal of the other fraction?
Positive 2 over 1. No. Or is it just -2 over 1.
-2 over 1. Yep. So we take the top one and we multiply by the bottom one flipped. And what's going to happen there when we multiply? So if we multiply straight across, we could do that, but there's something that might happen first.
Did the 2's cancel out?
Right, 2's cancel out, because we have a 2 in the top and a 2 in the bottom. Now when we multiply straight across, it got a little bit easier. What's left in the top? Negative and something else. Negative square root of 3. And what's left in the bottom? Right, just a 1, but we don't need to divide by 1 because that doesn't change it. So that is our answer. Okay, negative square root of 3. Any question on that? Right, now once we have the 3 that are on the left, what was the pattern to get the 3 that were on the right? Just the reciprocal. All we have to do is take and flip them. Okay, so let's start with the cosecant. To get the cosecant, you got to take the sign and you flip it. So what would the cosecant be?
2 over 3.
2 over,
Because you got to flip it to square root of 3 to the bottom.
so square root of 3. So that's the first step.
Then you multiply square root of 3 over square root of 3.
Yeah, and we got to multiply to fix it. So we did, the trig part was just flipping. Okay, that's done. This part is just arithmetic. You can't leave a square root in the bottom, and that's anytime you have a square root, not just trig. What would that give me in the top?
2 square root of 3.
2 square root of 3. And what would it give me in the bottom?
Square root of 9.
Square root of 9, which is 3. And that's your answer. Okay, so 2 square root of 3 over 3. How about, just put this down here. How about the secant? What's that going to be? -2. Yep. So you're going to take -1/2. There's no square root in that one, so that one's a lot easier. We're done. And now the cotangent. Well, we have to flip this, but we don't have a fraction. If you want to make it a fraction, you can. What could you put in the bottom? Yeah. If it helps you because you don't have a fraction and you want to make it a fraction, put a 1. And Ruben, what's going to be my first step to get the cotangent?
Take the x value divided by the y value.
Okay, but we already have the tangent, so what could we just do with that, which would be easier? Well, what's the connection between the tangent and the cotangent?
They're just flipped.
They're just flipped. So we've got the tangent, so to turn it into the cotangent, all we have to do is flip it. What do you get when you flip the tangent?
You get 1 over square root of 3.
You get 1 over,
Square root of 3. Negative square root of 3.
right. Where we put the negative, it doesn't really matter. You could keep it in the bottom. I usually just put negatives in the top. But yeah, it has to stay negative. Right? And same problem we had with the cosecant. We just have to fix that. And what do we multiply by to fix that?
Square root of 3 over square root of 3.
Square root of 3 over square root of 3. And anyone think they can give me my final answer for the cotangent?
Negative square root of 3 over 3.
Yep. Square root of 3 over 3. Okay, what we just did there, that would be 6 different problems on the test. Okay, but we just did all 6 in one question. Right. Any question on how we got those 6 trig functions? Let's try another one, this time a little bit different. Are they giving me a coordinate or am I finding it? Yep, they're giving me the coordinate again. Okay, that's better. When they give you the coordinate, that's an easier problem. When they don't give you the coordinate, like this, now you've got an extra step. You've got to think about 90, figure out the coordinate, and then do the problem. But this time, they're giving us the coordinate. All right, so let's start with the sine. Jade, what was the definition again for sine? It's just the y. And what's the y value in this case?
Square root of 2 over 2.
Yep. If you accidentally mixed up the x and the y in this problem, you'd be okay because they're the same. But in general, they're not the same. This one's just a special case. Okay. How about cosine? What's the definition for cosine? X. And what's the x in this case?
2 square root. Square root of 2.
Square root of 2 over 2 again. Again, sine and cosine, easiest to do because they're given to you directly. Everything else we either have to divide or flip to figure out. Tangent. What's the formula for tangent? Y over x. And what do you get if you divide y by x this time? Yeah?
We should get 1 because they're the same.
Right, they're the same. Whenever you divide two things that are the same, you get 1. Okay, if we want, let's do the cotangent because that one's quick. The cotangent is when you flip the tangent. Well, what do you get if you flip 1? 1. It stays the same. There's 2 things you can flip and they stay the same. That's one of them. If you flip 1, you get 1. Anybody know the other number you can flip and it stays the same? No, if you flip 0, you get undefined. Because when you flip 0, you're putting 0 in the bottom of a fraction, and you can't have 0 in the bottom of a fraction.
Is it -1?
-1. Yep. All right, let's do the cosecant. What's the first step to get the cosecant?
Flip it.
Flip which one?
The y value.
Yep, flip the y value. So we already got the y value, root 2 over 2. What do we get when we flip it?
Well, when you flip it 2 over square root of 2.
2 over the square root of 2. Okay, that's a good first step, but we ended up with a root in the bottom, which we need to fix. And what do we multiply by to fix that?
Square root of 2 over square root of 2.
Square root of 2 over square root of 2. And now multiply straight across. What do you end up with in the top? 2 square root of 2. And what do you end up with in the bottom? 2. But what does everything that's on the outside of the root have in common? What are they? Well, I guess what are they all divisible by? Right. So these 2's end up canceling out. And your final answer is just square root of 2. Because you're timesing the top by 2, and then you're dividing by 2. Well, if you times 2 and divide by 2, cancel out. And how about the secant? Same thing. Okay, we don't need to waste time to do it all again because the sine and the cosine were the same. So the cosecant and the secant are the same. Any question on that? Okay, so that's how you do it when they give you the coordinate. Let's try one that's different. What's different in this one?
You gotta find the coordinate.
Right, you have to find the coordinate. They've given you the angle. Okay. For unit circle trig, the angle, that is not directly helpful. It's indirectly it'll help you. But the thing that is directly helpful is the coordinate. That's what you need to figure out. Okay, so now we got to think about 90 degrees. So think about your circle. Where's 90 on the circle? It's at the top. So now you have to remember the coordinate when you are at the top. And that's why I showed you before that we just did. What was the coordinate at the top?
0, 1.
0, 1. Okay. The nice thing about working with an angle that has right on an axis is it'll never have a square root there. It just has a 0, a 1, or a -1. So the arithmetic is generally easier. Okay. So we've got the coordinate. Now we do the same thing we did before. Okay. What's the sign? 1. Yep. About the cosine? 0. And what about the tangent? Can you give me the whole fraction? 1/0. What happens when you take 1 and divide by 0?
0.
That's undefined, right? You can't divide by 0. So the tangent of 90 is undefined. Means you can't do that. There is no such thing as the tangent. And there's reasons why, which we'll talk about later on, why it's undefined. But that's why it's undefined in terms of the coordinate. You're trying to divide by 0. Okay. How about the cosecant? Yep, that's going to be 1. If you're confused because you don't have a fraction, then make it a fraction. Just put a 1 in the bottom. And you flip 1/1, you get 1/1. How about the secant of 90? That's undefined. Again, think about that as a fraction. If you flip it, it would be 1/0. It's exactly the same as this one. So it's undefined. And the way that would be on the test is you'd be able to just type in undefined. And how about the cotangent of 90? 0. Yep. So these two rows are kind of a special case. When you flip 0, you don't get a number. You get undefined. And when you flip undefined, you get 0. Other than those two, there are no special cases. Questions on that one? This one's pretty similar. A couple things that are different. First, they're only asking for the first 3 trig functions instead of all 6. And what else is different here?
Change it to degrees.
Yeah, what's 3 pi? Well, I mean, just in general, I'm not looking for a number, I'm looking for a word. Yeah, this is radians. So this time they're giving you an angle, which first of all isn't directly helpful with this because you need a coordinate. And second of all, they've given you an angle that's not even what you're used to working with. It's in radians, not degrees. So what do you think we want to do with that 3 pi? Let's change to degrees. We did this at the beginning. What do you multiply 3 pi by? 180 over pi. So pi's cancel. And what's 3 times 180? Remember, this is a 1 in the bottom, so you're not dividing by 3. You've got to multiply the 180 by 3. 540. Okay. So we're working with an angle that's 540 degrees. So I didn't really like the 3 pi because it was in radians. I still don't even like the 540. It's in degrees, but what do you think I don't like about 540?
It's too big.
It's too big, right? 540 means you've gone around more than once. It's more complicated to think about the coordinate. What can we do to make the 540 smaller? We can minus 360. So you minus 360 and you get 180. Yeah, you'll get 180. 180. Now we finally have an angle that's equivalent to what we started with, but it's in degrees and it's smaller, so the coordinate's easier to find. What's the coordinate for, well actually, where is 180? It's all the way on the left. And what's the coordinate on the left side? -1, Okay. So now we'll go through our trig functions. Holly, what would the sine be? Do you remember the definition for sine? You want to help her out? What's the definition for sine? It's the y. And what's the y value of our coordinate here?
0.
0. So the sine is 0. Serenity, how about the cosine?
X.
Yep, it's the x, and in this case, the x is -1. Yep. And how about, Lucas, what's the formula for tangent?
Y over X.
Yep.
So it's just, 0 divided by -1.
0 divided by -1, which is
0.
0. Yep. 0 in the top is perfectly fine. 0 in the bottom, that's undefined. Yep. And then if we wanted to find the other 3, which we're not going to, but what would we do to the 3 that we have? Well, yeah, just flip them. Undefined, -1, undefined. So we could do them all out, but that's all I want to do for now. Any questions on that? All right, I think I just have a couple more. That's pretty much it. All right, find the 6 trig functions of 11 pi over 2. Okay, what have they given me this time? They've given me radians, and in general, radians is used to describe how big a what is? An angle. So yes, they've given me an angle, but what do we really need to do unit circle trig?
A degree.
Not even a degree. Degree might help you to get what you need,
Oh,
but
correct.
we really need the coordinate. So if you know the coordinate for this right now, then you can just write the coordinate. If you don't, what's going to make the coordinate easier to find?
Degree.
Change to degrees. Yep. So changing to degrees is only if you don't know how to figure out the coordinate. Maybe that'll help make it easier for you. So we got 11 pi over 2. What do we multiply by to get it in degrees? 180 over pi. Okay. And what's going to happen there? Pi's are gone. Anything that I could do first to maybe make the numbers a little easier to work with?
Simplify 180 and the 2.
Yeah, what's 180 divided by 2? 90. Now I got a little bit of smaller numbers to use. What's 11 times 90? 990. Okay, is the coordinate appearing to you right away, 990? If you're not telling me within a second or two, then it's not appearing right away. Why is that one a little hard to think about?
Yeah, subtract 360.
Right, it's too big. If we subtract 360, we get 630. Now what?
Do it again.
Do it again. Now you should be getting a number that the coordinate jumps out pretty quick. Where's 270? That's the bottom. Okay, when I asked where 990 was, what the coordinate was, nobody was able to do it right away because it's too big. But 270, we knew right away. It's at the bottom. What's the coordinate when you are at the bottom?
0.
Much easier to figure out the coordinate now. 0, -1. Okay, so let's start with the sine. Kim, what's the sine here? Yep. It's the y value, which is -1. Ryan, how about the cosine?
0.
0, that's the x value. And Gianna, what about the tangent? Undefined, because it's the y value divided by the x value. I just imagine putting a fraction right there. That's the tangent. Y over x. -1 over 0. Okay, cosecant? -1. That's the one that stays, well, one of two numbers that stays the same. The secant is undefined. And the cotangent is, when you flip undefined, you get 0. questions on that? All right, so today we looked at what the definitions were for the trig functions, and I had you guys find coordinates as long as the coordinate ended up being one of those four in red. Okay, tomorrow we're going to look at what happens when the coordinate is somewhere in quadrant 1, and it's either going to be a 30, a 60, or a 45. And you've already seen those coordinates today in some of the problems that we did. So that coordinate's going to come up a lot tomorrow, and so is that one. All right. So you've got a good amount of time to work on your homework, 25 minutes. We might not end this early every day, but today is a little bit shorter. So 11 to 27 odd and number 22. So please use the time to try to get started on that. If you happen to finish it, you can show me, and then there's no homework other than that for tonight.